Click the bell icon to get latest videos from Ekeeda.
Hello friends, I welcome you all to the subject Electromagnetic Field Theory. This video is from chapter number 11, that is plane wave reflection and dispersion. The plane wave reflection up till now we have seen for first of all the normal incidence for a boundary separating the two general mediums characterized by the conductivity, permittivity and permeability. We have solved few problems based upon to that. The second medium latter we selected to be the perfect conductive medium to have the total reflection back to the medium number 1. Now after that we have seen the standing wave ratio, the reflection at multiple interfaces, and finally the generalized one, that is oblique incidence. If the traveling wave is not making exactly 90-degree with the boundary surface, so that time we have the condition of the oblique incidence. And in the previous video we have seen how we can have the total internal reflection or the total transmission of the incident wave. So based upon to those factors, we have solved one problem also where we had the total internal reflection by the angle of critical angle of incidence. Now let us take one more problem where we will be having the condition to use for the total transmission. So this is our problem statement. A right circularly polarized plane wave in air is incident at Brewster's angle on the semi-infinite slab of material having epsilon r is equal to 3.45, sigma equal to 0, mu equal to mu 0. We have two parts. Determine the fractions of the incident power that are reflected and transmitted, and in part B, describe the polarizations of the reflected and transmitted waves. So the thing is very much clear in this problem that we have the incident wave. So that incident wave is originally right circularly polarized plane wave. In the last chapter, that is uniform plane waves, the last topic we have seen, that is wave polarization. So the type of polarization depends on how the orientation of E field vector varies into the space. So if it is having a tilt onto the right hand side, viewing from the receiver's location, we say right circularly polarized. So this is the type of polarization we are provided. The most important thing is it is coming from air. While solving the problems based on to the reflection, transmission at oblique incidence or normal incidence, it is better to first of all understand which particular mediums are there. So air will be the medium number 1. Hence we can have the conductivity sigma 1 will be equal to 0, the permittivity given by epsilon 1, and the permeability given by mu 0 to hold the constant values that we know. Now what is the second medium? The second medium is having semi-infinite, so dimensions are given. Air is also semi-infinite in this case. So it is slab material having the epsilon r 3.45, sigma conductivity equal to 0, and permeability given by again that of the free space, that is mu 0. So let us show first of all these two materials into this particular diagram. So let us say this is the boundary surface. The medium one we have air medium. In this air medium, sigma 1 will be equal to 0, epsilon 0, and the mu 0 are the parameters of permittivity and permeability. For the slab material, we have relative permittivity. So epsilon r2 I mentioned, this is 3.45. Conductivity sigma 2 is equal to 0, and permeability mu 2 will be equal to mu 0. So these are the mediums separated by this particular boundary. Now a right circularly polarized wave is incident at Brewster's angle. Brewster's angle, that relation we have seen for total transmission. So let us say at this boundary, if this is the normal to this particular boundary, this is the incident wave. Now the angle is supposed to be the Brewster's angle. Now what is the question exactly? We have to determine the fraction of incident power that is reflected and transmitted. So the reflected portion and transmitted portion at the condition of Brewster's angle from the previous video of theoretical topic that we have to utilize, and further we have to comment on to the polarization types of the reflected and transmitted waves that we determine into the part A. So let us begin to solve this particular question. Now, Brewster's angle is mentioned here. Now, as per the information with us, the Brewster's angle, we denote it by theta suffix b, and we have the formula that incidence angle theta 1 will be is equal to theta suffix b Brewster's angle, given by the formula tan inverse of the relative permittivity of medium 2 to that of the relative permittivity of medium number 1. So here if we make substitutions here, tan inverse of, so epsilon r2 is with us and it holds the value 3.45, and epsilon r1 for air medium it will be equal to 1. So this becomes, so finally we have the angle Brewster's angle theta sub is b to hold the value 61.7 degrees here. Now, from the Brewster's angle, if you need to take the value of the angle of transmission or angle of refraction in terms of light theory, if you say, so theta 2 will be equal to 90 degree minus theta sub x b. Therefore, we obtain theta 2. So, theta 2 will be equal to 28.30 degrees. 28.30 degrees. Now, we are said that the incidence at the Brewster's angle is there, and at this particular Brewster's angle, if we have such a right circularly polarized plane wave incident, so that time we will be having the p polarized wave to be completely transmitted. P polarized wave will be completely transmitted, whereas the S polarized wave will be having the complete reflection at Brewster's angle. So therefore, for the S polarized wave, the complete reflection, by using the reflection coefficient, we can mention that is gamma sub x r given by the eta 2 for the S polarization minus eta 1 for S polarization divided by the sum of the two. So this we can substitute with the values of this particular one. So for S polarized wave, the medium one will give us eta 1 S will be equal to eta 1 in general into sec of the angle theta 1. So this is for the free space eta 0 into sec of the angle that we have, that is 61.7 degrees. Therefore, this happens to be 2.11 eta suffix 0, and eta 2s for S polarized, it will be eta 2 into sec theta 2, that will be eta 0 divided by under root 3.45 sec of, it will be 28.3 degrees is equal to 0.614 eta 0. Therefore, the reflection coefficient, the gamma suffix r, give us the reflection coefficient for the S polarized will be 0.614 eta 0 minus 2.11 eta 0 divided by the addition. So 0.614 eta 0 plus 2.11 eta 0 will give us the reflection coefficient 0.549. So thus reflection coefficient is obtained. Hence, if we require the total reflected power fraction, so that time we shall be having the magnitude square. So it will be minus 0.549 squared to give the value 0.302. So now, since the wave is right circularly polarized, so that time the S polarized component will be one half the total power. Therefore, 0.302 that we have obtained, it will be divided by 2 to obtain the value 0.15, or we can say that this is the 15% of wave power is reflected for S polarized. So S polarized here, and this one is reflected. Now, if 15% for S polarized is reflected, we can say that the 85%, that is remaining one for the S polarized, will be transmitted for the another component. Now, in the part B, we are asked if we get back to the problem statement, the reflected and transmitted portions that we have determined, this is 15% and this is the 85%. Describe the polarizations of the reflected and the transmitted waves. So since all the p polarized waves are transmitted here, the reflected wave will be entirely s polarized, and the transmitted wave, while having all the incident p polarized wave, will have the reduced s component. The transmitted wave will have reduced s component. Therefore this wave will be right handed elliptically polarized. Elliptically polarized. Hence, for different types of polarizations of linear type, S polarization and P polarization into consideration, with the help of the Brewster's angle or the total angle of incidence at the critical stage, the total reflection, total transmissions or oblique incidence of the waves can be determined. So for getting such more topics of this particular subject, electromagnetic field theory, you can subscribe to Ekeeda channel.